Hi guys, today we will discuss about special semiconductor devices. In special semiconductor devices, we are going to discuss about DIAC and TRIAC. First, we will discuss about DIAC. So DIAC stands for what? Diode alternating current. It's a two-terminal, four-layered bidirectional semiconductor device. So why it is called as two-terminal device? Because it is having the two terminals, that is one is anode 1 and anode 2, as you can see from the figure. And it is called as the four-layer device, means it consists of two four-layer devices, as you can see from the construction. That is, the first four-layer device is the P1, N1, P2 and N2, and second one is the P1, N2, P2 and N3. And it is called as the bidirectional switching device because it is going to operate for the both the values of the applied voltage, means either you can apply the positive voltage or you can apply the negative voltage. Hence it is called as the bidirectional switching device. And you can see from the structure or the construction, that is, it consists of two four-layer diodes are connected with each other, and the figure B is going to show its symbol. So from the symbol you can see that there are two terminals are there, one is anode 1 and anode 2. The top terminal is called as anode 1 and the bottom terminal is called as the anode 2, and figure A is going to show its structure as I said before. Then how the DIAC is going to work? So as I said, DIAC is going to work for the both the polarities of the applied voltage. Either you can apply positive voltage or you can apply the negative voltage. So figure A is going to show where the two diodes are connected in anti-parallel fashion, or two four-layer diodes are connected in anti-parallel fashion. The first diode are denoted as DS1 and second diode is denoted as the DS2. And figure B is going to show where the equivalent circuit by applying the positive voltage as well as the negative supply voltage. The first side, that is the leftmost side, is going to show you the whenever I am going to apply the positive supply voltage, and rightmost side is going to show when I apply the negative supply voltage. The first case, when I apply the positive supply voltage, under that condition, initially when you apply the positive voltage, that is by making anode 1 positive with respect to anode 2, under that condition initially there will be a very small amount of current is going to flow. That current we call it as the leakage current. And then as you go on increasing the value of the applied voltage up to certain value called as VBO. VBO is nothing but the threshold voltage. The current will be very small. Once the applied positive voltage becomes equal to or greater than the VBO or breakover voltage, under that condition the current through the DIAC starts increasing and the DIAC starts conducting. Once the DIAC starts conducting, from that condition the current goes on increasing whereas the voltage goes on decreasing. This is in case of for the applied positive voltage. Then coming to the right hand side, when I am going to make anode 1 negative with respect to anode 2, or I am going to apply the reverse or negative voltage for the DIAC. So when I apply the reverse voltage, under that condition, again initially there will be a very small amount of current is going to flow, that is nothing but the leakage current, which is going to be because of the minority charge carriers. And as I go on increasing the negative reverse voltage, again same like in the first condition, after reaching the breakover voltage, negative breakover voltage, the current to the DIAC starts flowing and the DIAC starts conducting. Okay, so this is how DIAC is going to conduct, and there will be a certain value of current will be there, that is called as the holding current. Holding current is nothing but that current below which the DIAC is going to comes into the off state. Okay, so the minimum current that is required to keep the DIAC in the on state is called as the holding current. So this is how the DIAC is going to work. Then next one is the VI characteristics of DIAC. You know that VI characteristics are nothing but the curve drawn between the applied voltage and the resulting current. So when I take the DIAC, as I said, it's a bidirectional device. So I have taken the characteristics for both applied positive voltage as well as the negative voltage. So in the first quadrant, where I am going to show the positive voltage characteristics, it is the curve that is drawn between applied forward voltage and the forward current, whereas the characteristics drawn in the third quadrant is nothing but it is the curve that is taken for the applied reverse voltage and the resulting reverse current. When I take the first case, so as I said before only, I am going to apply the forward voltage, that is the positive voltage. When I apply, I am going to make anode 1 positive with respect to anode 2. Under that condition, initially there will be a very small amount of current is going to flow. That current is nothing but we call it as a leakage current, and the small amount of leakage current will be flowing up to the applied forward voltage reaches certain value called as the VBO or breakover voltage. Once the applied forward voltage becomes greater than or equal to the breakover voltage, the current through the diac starts flowing and the voltage, that the applied forward voltage, starts decreasing. And I have shown is certain value of current called as IH, that is nothing but holding current, below which the diac enters into the off state. This is for the forward characteristics. When I come to the reverse characteristics, it is the curve that is drawn between the applied reverse voltage and the reverse current. So when I apply the reverse voltage, under that condition, initially again there will be a very small amount of current will be flowing, that is the leakage current, and as I go on increasing the applied reverse voltage up to the value called as negative breakover voltage, the current value will be very small. Once the applied reverse voltage reaches the negative breakover voltage or minus VBO, from that point onwards the current through the diac starts increasing and the diac starts conducting, and as the current goes on increasing, the applied voltage goes on decreasing. So this is called as the VI characteristics of diac. Then next is, what are the simple applications of diac? So the simple applications of diac are, first one is it is used for triggering the TRIAC, or to make the TRIAC as turned on I can use the diac. Then second one is it can also use for the heat and light controlled circuit. And third one is it is used for the speed control of the motors. And fourth one is it is used for temperature control circuit. And fifth one, it is also used for the domestic applications or the household applications. In that one it is used in case of the air conditioning applications. So this is about the DIAC. Hope everyone has got it. The next one is we will discuss about one more semiconductor device, that is nothing but the TRIAC. TRIAC stands for triode alternating current. Similar to DIAC, it is also same way it is going to work, but it is having the 3-terminal bidirectional switching thyristor device. So same like your DIAC, it also conducts in the both the directions, that is for a positive voltage as well as for the negative voltage. The only difference is the DIAC will not be having any controlling terminal, whereas the TRIAC will be having the controlling terminal called as the gate terminal. Okay, so if you see the structure of the TRIAC, it is having 3 terminals, that is denoted as the main terminal 1, main terminal 2, and the controlling terminal, it is denoted as the gate. And same like this also, it is having the where 2 diodes connected in the anti-parallel fashion. And figure B is going to show you the symbol of the TRIAC, that is gate terminal MT2 and MT1 terminal is going to be connected. Okay, then working principle of TRIAC, as I said, the same way how the DIAC is going to work, the similar way the TRIAC is also going to work, but it is also going to work with the help of the gate terminal, it is nothing but the control terminal. So means I can work to TRIAC without the gate voltage or with the gate voltage also. So initially I'll take that as MT2, that is main terminal 2 made positive with respect to MT1, and I am not applying any gate voltage, or the gate is kept as open. When the gate is kept as open and main terminal 2 is made positive with respect to main terminal 1, again initially when the applied voltage, that is the applied positive voltage across MT2 is less than the VBO, that is the breakover voltage, the current flowing through the TRIAC is very small, that I call it as the leakage current. And as you go on increasing the applied voltage, when the voltage across MT2 is going to reach certain voltage level called as breakover voltage, the TRIAC starts conducting and current through the TRIAC goes on increasing. As the current through the TRIAC goes on increasing, the applied voltage goes on decreasing. So this is when I apply the forward voltage. But what happens if I apply the gate voltage? Because this is the condition where I kept the gate as open. Suppose if I make gate voltage as apply certain value, under that condition what difference it is going to make is, whenever I apply a gate voltage, under that condition the breakover value of the breakover voltage becomes less compared to the without gate voltage. Okay, so this is for the forward voltage. Then what happens in case of the reverse voltage? So in case of the reverse voltage, it's nothing but the main terminal 2, that is the MT2, is made negative with respect to MT1. So again, if I take the gate is open, or I am not going to apply any voltage across the gate terminal. So in that condition, as I go on applying the voltage, that is the negative voltage across MT2 or the reverse voltage, initially there will be a very small current will be flowing, that is nothing but the leakage current, and is go on applying the voltage. When the reverse voltage reaches certain value called as VBO or breakover voltage, the current through the track starts flowing and the track comes into the conduction state. Okay, and when you apply the gate voltage, again the value of breakover voltage reduces with respect to the apply voltage. Means when you apply the gate voltage, the value of breakover voltage is less compared to the when you not apply the gate voltage. Okay, so this is how the track is going to work. Then next one is the VI characteristics of TRIAC. So VI characteristics of TRIAC, again as I said, it is nothing but it can be same like TRIAC. It will be taken in the first quadrant and the third quadrant. First quadrant I am going to take the forward characteristics, and in the third quadrant I am going to take the reverse characteristics. So the first one is the characteristics which I am going to draw in the first quadrant, that is nothing but the characteristics or the curve which I am going to draw in between the forward voltage and the forward current. So when I apply the forward voltage, that is when I apply MT2 positive voltage with respect to MT1, under that condition, as you can see from the figure, initially there will be a very small amount of current will be flowing, that is nothing but the leakage current. And once the applied forward voltage reaches the value called as the VBO or forward breakover voltage, from that condition onwards the track goes into the conduction state and current through the track goes on increasing. And once the current through the track goes on increasing and the voltage goes on decreasing. This is when I am going to make Ig is equal to 0 or the gate current is equal to 0, or it means that I am not provided any voltage for the gate terminal. Then if I provide the gate value, or if I provide some value for the gate terminal, then under that condition what will happen is, you can observe from the figure, same response we are going to get, but the only difference is you can see the value of the forward voltage, that is VBO, when the gate is open is high compared to the value of the VBO when I apply certain gate value. That is when Ig is equal to 0, the value of the VBO is more compared to when I am apply certain value for gate voltage, that is Ig1 and VBO1. Similarly, when I increase the gate voltage, that is nothing but the Ig2 and the corresponding breakover voltage is VBO2. So what it tells you is, when you make gate voltage as 0, the value of the breakover voltage is more, and you go on providing the gate voltage, the value of the breakover voltage decreases. Okay, so this is for the forward characteristics. Same thing is going to happen for the reverse characteristics also. Here you are applying the reverse voltage and you are going to get the reverse current. Okay, so initially when you apply the reverse voltage, or you are going to make MT2 negative with respect to MT1, initially when you go on increasing the voltage, so there will be very small amount of current will be flowing, that is nothing but your leakage current. And once the applied voltage reaches the value called as negative breakover voltage or reverse breakover voltage, from that point onwards the current through the track goes on increasing and the voltage goes on decreases and the track enters into the conduction state. So same like forward characteristics also, here initially when I make gate voltage as 0, the reverse value of the breakover voltage is more, and as I go on providing certain value for gate voltage, the value of the breakover voltage goes on decreasing. Okay, so this is how the characteristics of track will be there in the forward and reverse. And here I have denoted at the certain values are IH0, IH1 and IH2. Those are nothing but, as I said previously, the holding currents. Yes, that is nothing but the minimum current value that is required to keep track into the conduction state. Okay, that I call it as the holding current. If the current value reduces below that value, then the track again comes to the off state. Okay, so this is the VI characteristics of track. I hope you have understood. Then next one is the applications of TRIAC. So TRIAC is popularly used in the one circuit called as light dimmer circuit for the illumination control, or to control the illumination level of the light, we are going to make use of the TRIAC. That is, in combination with the DIAC, the TRIAC can be used in the light dimmer circuit. Also, the TRIAC can also be used for the temperature control, phase control, and the liquid level control. And also the TRIAC can be used for the power switches, where it can be used as a switch, and it can also be used for motor speed regulator for the regulator purpose. So these are the certain applications of TRIAC. So hope you have understood whatever I have explained about the DIAC and TRIAC. Thank you.